Now let's start with some notations. Uh, so you will see this notation a lot in this one here. So when we give you the power here 2 or 3, we mean it's the power of cosine theta and the power of sine theta here. So it's not, this is not equal to cosine theta squared for sure. And also this is not equal to cosine theta squared. So basically when you see cosine squared theta, it means cosine theta squared. So here's an example. If cosine theta is this, so cosine squared theta is equal to square root 3 over 2 squared, which is 3 over 4. And the same thing happens here. For sine cubed, we have the same thing. Sine cubed theta means sine theta cubed. So you're taking sine, if sine theta is equal to negative 1 over 2, you're taking the cube of it. So it's sine cubed theta is equal to minus 1 over 8. So after this notation, we can start Pythagorean identities. These identities basically follow from the right triangle. So it can follow from the right triangle. So let's see the first one here. Let this be A, B, C, and we know by Pythagorean theorem, C squared is equal to A squared plus B squared. Now let's look at this one. What is sine theta? Sine theta here is, we know it's B over C, and cosine theta is A over C. Now if you take the square both sides, I mean square of the both sides, you will get sine squared theta, and you will get cosine squared theta as A squared over C squared. Now when you add them, so sine squared theta plus sine squared theta will be equal to B squared over C squared plus A squared over C squared, and this will be B squared plus A squared over C squared, and which gives us, okay, by Pythagorean we have this one, B squared plus A squared is equal to C squared, so it has to be 1. So this follows from this right triangle if theta is an acute angle, but if theta is other types of angles, so since we are dealing with the squares, so sine theta or its value will be just plus or minus depending on the reference angle, so the equality still holds. And okay, let's think about this, how this happened. Okay, tangent theta is equal to B over A. Now, what is tangent squared theta? This is B over A squared, which is B squared over A squared. And let's add 1 to both sides, and let's see what happens. So when you add 1 to both sides, you will get, okay, you can do like 1 over 1, so you get B squared over A squared plus A squared over A squared. And this will give you, together, it will be, again, from the Pythagorean, it will be C squared divided by A squared, and which is equal to C over A squared. What is C over A? C over A is the secant theta, so it will be secant squared theta. And since we have the squares all the time, so it will be this equality will hold all for positive and negative trigonometric values of tangent and secant. So theta can be any theta, not an acute angle, but it might be big obtuse angle or the other type, any angle. So 1 plus cotangent squared theta. Okay, what is cotangent theta here? Cotangent theta is A over B. So this is like 1 plus A over B squared. So 1 plus A squared over B squared. And then when you add, you get B squared plus A squared over B squared. B squared, A squared means C squared, you know, from the Pythagorean. So you get this one as C over B squared, and which is C over B squared is C over B squared means 1 over sine. So 1 over sine is indeed cosecant theta. So it will be cosecant theta squared. So we get now this one. Now they all follow from the right triangle. So for the acute angle, it follows from the right triangle. So we call them Pythagorean identities because they're all following from the Pythagorean theorem. We use it. We have seen it. Okay, and there are also some other ways to to show them. We can also say the unit circle in the everything in the unit circle, like this cosine theta, sine theta here, and obviously cosine theta, sine theta squared. So the distance from 0, 0 to cosine theta, sine theta will be equal to 1. So we can write it this way: cosine squared, sine squared theta is equal to 1. And after this, it's another issue is we can write this one, then after writing this, like sine squared theta plus cosine squared theta, divide both sides with cosine squared, you will get 1 over cosine squared, and this will give you tangent theta squared. This will give you plus 1, and this will give you secant squared theta. This is another way of showing it. Okay, I don't want to show the other one, but let's see how it goes, like in the slide. So dividing the sine squared plus 1, dividing by sine squared, we will get this inequality. This equality here, this identity. Okay, if it is true for all theta, for all real numbers, all theta real numbers, we call them identity. Now let's use them in our questions here. Okay, given tangent theta is equal to 3 over 4, and theta is an angle in standard position with a terminal side lying in quadrant 3. So basically it's asking tangent theta is 3 over 4, it's given. And theta is in Q3, this is also given. Now it says, in A, it says, what is the cotangent theta? Now we solved this type of questions. You can use the reference angle or the other things, but the very straightforward thing here you can use is the relation between cotangent and tangent. So cotangent is equal to 1 over tangent, so it has to be 1 over 3 over 4. So this has to be 4 over 3. Now, we have seen, we were finding this, with some other methods, find it and then put it here and then check the reference angle and, but here it's easy to use an identity. Now let's look at here secant theta. So we want to find secant theta, and is there a relation between secant theta and tangent theta? So secant theta and tangent theta in a relation. Okay, let's remember the Pythagorean identities. One of the Pythagorean identities, if you remember, and you have to memorize, by the way, 1 plus tangent squared is equal to secant squared theta. So from here you can say 1 plus 3 over 4 squared is equal to secant squared theta. And now by solving this, you will get secant squared theta is 5 over 4 squared. Okay, do the calculation. And we have two options for secant theta. Either secant theta is equal to plus 5 over 4 or minus 5 over 4. But here comes the question, which one? Now here we want to use this thing here. It says Q3 theta in Q3. We know it, right? So theta Q3 means secant theta, which is 1 over cosine theta, is what? So all STC, if you remember all STC, STC, and we're talking about the third part. The cosine is negative. Cosine negative means 1 over cosine, which is secant, is negative. So we say this is negative, so we have to take this one. So we don't accept this. So secant theta will be equal to minus 5 over 4. So we get this one as minus 5 over 4. So this is 4 over 3, we said. Now let's look at secant theta. Again, okay, let's write here tangent is 3 over 4 and theta in Q3. We know these are given. And what about sine theta? Okay, how can we find sine theta? So what is the relation between sine and tangent? So any relation, any identity involving sine theta and tangent theta? Okay, how can we do that? Sine theta will be used in secant theta. For example, we don't have direct relation between these two, but I think we have this one here. We have cotangent theta squared plus 1 is equal to cosecant squared theta. Now, how I will relate this one, because this here is sine, this is 1 over sine theta squared. So, and then here, this cotangent squared is like 1 over tangent theta squared. At least I can use tangent theta here, and I can get sine theta. Now, so you have to know the identities and how to do the manipulations, like how to get to the result. You have to know the relations very well. So I will do what is cotangent theta? It's 1 over tangent theta, and which is we know from A, or like 1 over 3 over 4, which is 4 over 3. Now, when you use this one here, I mean, well, I will use this cotangent theta squared. This is 4 over 3 squared plus 1 is equal to cosecant squared theta, and this will give you, okay, 525 over 9 is equal to cosecant squared theta. And what does this mean? This means it's 1 over sine squared theta. Now, what does this mean again? This means sine squared theta is equal to 9 over 25. So we have two options here. Sine theta is 3 over 5 or minus 3 over 5. But the thing is, theta is in Q3. So sine, okay, all STC, use all STC. So here, the sign will be negative, right? Only tangent is positive, so sine will be negative, so we don't take this one. Sine is negative here in Q3. So we say we take this one, so the answer will be negative 3 over 5. Okay, now I want to, okay, after this, I want you to see also the slides, how it goes, and I want to see them also. Now, these are given to us. The tangent is 3 over 4, and the theta is in quadrant 3. So the first one goes with, as I said, cotangent is 1 over tangent theta. And the other one goes with this, and we use this one here, tangent squared plus 1. So we use also the sine of secant theta in quadrant 3, and it will be minus 5 over 4. And in the other one, we use cosine theta is equal to 1 over secant theta. Okay, is it asking cosine theta anyway? And then, okay, this is another way of doing this. I think it's using, so here, this question, this answer is using another approach. So I try to make this one tangent theta is equal to 3 over 4, right? Okay. And here, secant, okay, the secant theta, it's coming from, I think, A, okay, from the part A, no, from part B, it goes from part B. So from part B, I guess, part B, we have -5 over 4, so you can use cosine theta is equal to, it's reciprocal, so it will be -5 over 4 over 5. And then you can use sine squared, cosine squared issue, and you get this one, and then you solve for sine, and you will get 3 over 4, 3 over 5, and its sine is negative in quadrant 3, it will be sine theta equal to -3 over 5. Now, here, it doesn't use my method, it goes directly from secant theta. From secant theta, it goes to, okay, from secant theta, here it goes to cosine, and from cosine theta, so using this identity, it goes to sine squared, sine squared, then it goes to sine. It goes this way, but in my method, before, I did it like this, cotangent squared theta plus 1 equal to cosecant squared theta. I said this is 1 over sine squared theta, and this is 1 over tangent squared theta. This you can use, and this is also okay. No problem. Both ways are fine. Now let's look at this problem here. If theta is an angle in standard position with terminal side lying in quadrant 2, so theta in Q2 it says, and sine theta is 1 over 3, it says calculate all 5 trigonometric values of theta. Now let's start with cosine theta. So what's the relation between cosine theta and sine theta? The sum of their squares is 1, so it will be sine squared theta plus 1 over 3 squared is equal to 1. So cosine squared is equal to 1 minus 1 over 9, so it will be 8 over 9. So cosine is equal to plus minus square root of 8 over 3. And which one? Okay, theta is in quadrant 2. Cosine is all STC. Cosine is positive in Q2. No, it's negative in Q2, sorry. All STC. Okay, your S is positive, but cos negative. So it has to be cosine theta has to be negative square root 8 over 3. Now we found it. Now, what can you say about tangent theta now? The tangent theta has this property, this tangent theta is equal to sine theta over cosine theta. Now, this follows from this fact here, like if you say this ABC, sine theta is A over C, and cosine theta is B over C, and then when you divide them, you will end up with A over B, so which is tangent theta. Now, this is also one of the identities following from the triangle, and we will use it frequently. Okay, this is an important one here. Now we can use tangent theta as, okay, sine theta, this is 1 over 3, and this is square root of 8 over 3, and then it will give you minus 1 over square root of 8. And what about cotangent theta? It's 1 over tangent theta, and which is equal to square root of 8. So you flip, the fraction. And then the others, like the cosecant is, we know its cosecant is like 1 over sine theta. So you flip sine theta, it will be 1 over 3, which is 3. Now the secant theta will be equal to 1 over cosine theta, and cosine theta is negative square root 8 over 3, and this will give us negative 3 over square root of 8. Now let's look at the negative angle identities. So these are following indeed. These are coming from the odd and even properties of trigonometric functions, as you will see here, cosine and 1 over cosine, which is secant. They're even functions. This is the even function property, and these are odd functions. So these are odd function property. So we already have seen them. These are, we will call them negative angle identities. Now let's look at this example. Let's see how can we use it there. Let theta be an angle in standard position in Q2. So theta in Q2 for sure. Sine theta is A, and A is between 0 and 1. And find cosine theta and tangent negative theta in terms of A. So this is in this question we will use A, not a number, but A between 0 and 1. Okay, how can we find cosine theta? So the first thing is the relation between cosine theta and sine theta is this. And what is sine theta? This is A. So we will have cosine squared of theta plus A squared is equal to 1. This will tell you cosine squared theta is equal to 1 minus A squared. Now when you solve this equation, like take the square root, you will get plus or minus. But here theta is in Q2. Theta in Q2, what does it tell us? Cosine is in Q2, it's negative. Cosine is negative by all STC. So cosine theta has to be minus square root of 1 minus A squared. Now, after we find this one, look, we found cosine theta, which is equal to square root 1 minus A squared. Then after this, how can we do it? Now, tangent minus theta is what? So by using the property here, the odd property, the odd function property, or the negative identity, we can take this negative out, and we will have this. This is tangent theta, which is sine theta over cosine theta. So we use this one here. Tangent theta is equal to sine theta over cosine theta, which gives us minus sine theta is what? A. And cosine theta here minus square root 1 minus A squared. Minus minus, it makes plus. So tangent negative theta turns out to be A over square root of 1 minus A squared. So we are done with this. Now the same thing is explained in this example here in this slide. So we can set up the Pythagorean identity for sine squared plus cosine squared. And from there, we can find 1 minus A squared. From there, we get plus minus. And then from the Q2, we have negative. And we use the negative tangent identity in this one here. It's an important one. And then we substitute and we get this result. Now let's look at this question. It says, what is cosecant squared theta minus tangent squared theta? And here, do we have any relation between do you have any identity? Do we know any identity? Involving like cosecant squared theta and cotangent squared theta. Remember the third one? Did you remember the third one? Okay, what was it? It was this, right? 1 plus cotangent squared theta is equal to cosecant squared theta. Now, what is cosecant squared theta? This is 1 plus cotangent squared theta. Okay, first let me write it here. Cosecant squared theta. Now let's write this one. Cosecant squared theta minus cotangent squared theta. Okay, what is this? It's okay. This is cosecant squared theta is 1 plus cotangent squared theta, and then we have the other one minus cotangent squared. They cancel out, and you get 1. This is so it's equal to 1. So can we do it in other ways? Yes, indeed. There are lots of ways of doing it. Now, one other way is to write this one as cosecant means like 1 over sine theta. So you can write it as like sine theta squared minus what is this? This is 1 over tangent theta. 1 over tangent theta is like tangent theta is sine theta over cosine theta. 1 over tangent theta means cosine theta over sine theta. And here it will be cosine theta over sine theta squared. So 1 over sine squared theta minus this is, you know, this is cotangent theta, by the way. Now this is cosine squared theta over sine squared theta. This is 1 minus cosine squared theta, and this is sine squared theta. You know, this is from cosine squared theta plus sine squared theta equal to 1. You can tell 1 minus cosine squared is equal to sine squared theta. So you will get sine squared theta over sine squared theta, which is 1. Usually there are 2 ways of solving it, so you can use different identities. It depends on your experience and knowledge about the topic. So if you have enough experience, you can directly say, hey, we know some identity involving cosecant squared and cotangent squared. Or you can go the other way. You can say, let me write cosecant as like 1 over sine, cotangent as like cosine over sine, and then you can proceed. So it depends on your experience and knowledge. Okay. Now this is okay. This is the second method I explained. Now let's try to do this. Write this expression in terms of sine x. So it says everything. Write everything in terms of. Try to write everything in terms of sine x. Let's try it. So cotangent is for sure it's 1 over tangent, and this 1 over tangent is like 1 over sine over cosine, and which gives you like cosine x over sine x. Okay, the cotangent is definitely equal to cosine x over sine x. So cotangent squared x is equal to cosine x over sine x squared, and which is equal to cosine squared x divided by sine squared x. Now, and okay, here then I will write this one as cotangent squared x times sine squared as sine squared x over sine squared x. So this is following from here, by the way. So, and then sine squared x. So this is a multiplication, and this is the here division. So they will simplify, and we'll have cosine squared x. Now this turns out to be cosine squared x. Now how about this part? Okay, this part here is tangent x times cotangent. What is cotangent, by the way? This is 1 over tangent x. So when you multiply, you will get them 1. So this gives you cosine squared minus 1. Now, this whole thing is equal to cosine squared minus 1. Okay, but the question here, can I write it in terms of sine x? Now, how? Okay, we can use this fact here. Okay, this means, okay, cosine squared means here equal to 1 minus sine squared x, right? So I can write, instead of cosine squared, I can write 1 minus sine squared x minus 1. So they will cancel out, and we'll end up with negative sine squared x. So the answer will be here. This will be equal to minus sine squared x. Now, we have another topic here. This is verifying the trigonometric identities. Verifying means, like, we will give you an identity, an equality, and you will start from the one side and you will try to go to the other side to show that the other side is equal to that expression by using identities. So here are some strategies. You will first look so we will have something here, something, and something. Okay, you will try to show from starting here, you will show this one, or you will start from here and you will show this one by using the identities. Now first, check which part of the equation or the equality is complicated. So start from there, and then use the identities here. And if you need, try to do the algebraic operations and use the factorization, expanding, adding, multiplying fractions, and whatever you do. I mean, try to do everything that will help your solution. I mean, that will help you to go to the other side. Now, and then keep the basic trigonometric identities in your mind. Okay, so you will use them. So they have to be in your mind. Okay. Now it says verify the identity. So which one is more complicated? I will start from here. So it looks more terms here. There are more terms on the other side. So it will be sine x. Let's cosine x. And now this will be equal to, okay, what is secant x? 1 over cosine x, right? So then I will multiply this with sine x plus cosine x. Then when you multiply them, okay, what happens is sine x over cosine x, and this will be cosine x over cosine x. And here, this will give you 1, and this is coming from the identity, this is equal to tangent x. So we started from the second part, and we get the first part. So the second part is equal to the first part. So the verification is done. So this is what is exactly I'm saying. Now verify the following trigonometric identity. Okay, which one is, okay, we start with the complicated one, okay, the more crowded part. So this looks the more crowded part, and we want to get here. Let's start. Okay, one thing we can do here is, like, we can try to expand this one first. This one. Okay, what's the square of it? Sine squared x plus 2 sine x cosine x plus cosine squared x divided by sine x. Okay, is this clear? I want to remind you this. Did you remember it? Okay. If you didn't remember it, please revise it. Okay. Please review your special products. Now, and the other side, it will be cosine x. Yeah, here. Okay, I'll write them this way. Now, what happens is we have sine squared x plus 2 sine x cosine x and plus cosine squared x and over sine x minus 2 cosine x. Now, okay, can I use an identity here? Let's check. Sine squared x plus cosine squared x. Okay, how about this? Sine squared x plus cosine squared x. What is this equal to? This is equal to 1. So I can write this then, okay. I can write this then. There's two of them. It will be 1. 1 plus 2 sine x cosine x divided by sine x. And then minus 2 cosine x. So how can I combine these two things? These are basic fractions. I mean, basically, there are two fractions and we want to combine them. So the best way is, and the easiest way is, make the denominator same. So how can I make it? There's sine x, there's 1. What will I do? Okay, the question comes to here. How do you do this? Let's say this. How do you do it? Do this, right? Okay, let's do the same thing for sine. So if it is sine, you will do the same thing, except it will be sine. So you will multiply with sine, multiply with sine. And let's do it. So here, this will be then sine x. This will be sine x then, right? So the numerators are same. So sorry, the denominators are same. So we can combine these two. Will be 1 plus 2 sine x minus 2 cosine x sine x divided by sine x. These two are same, right? So, but there's minus, cancel them out. So you will get what? 1, the resulting equality will be, okay, it's starting, okay, you can make this. It will be 1 over sine x. What is sine x? Sine x is cosecant x. Okay, maybe it should be this way, like, because we want to get to cosecant x at the very end. Now we obtained the second part. So we started the first part. So, okay, all the way it goes like, now it goes this way. We started, we came here, and we do this. The next, we combine them, we simplified. Then at the end, we came to the second part. So we end up with the second part. So it means we verified it. Okay, now you can see also the steps here. Okay, I think maybe it's more, okay, it's clear, I guess, at least more clear than mine. So it says like a step 1, you know, do the square, and then step 2, it goes like this. As, you know, expand, and then you can expand and you can, you know, separate them, these two, like here. Or yeah, You can combine them and use the sine squared plus cosine squared, right? One. This is what exactly I did. Now let's do another example here. Verify the identity. Okay, let's start from the complicated part. So cosine x over 1 minus sine x minus cosine x over 1 plus sine x. How to combine these two? This is the problem. Okay, let me ask you this question. Assume you have some question like this. Okay, assume this is like A only, so how do you do it? So you do common factors, right? I mean, you do a common denominator. So how do you make the common denominator? So if they are totally different things and there's nothing common between them as factors, you multiply each other with the other one. So you will get like c times 1 plus a, or 1 plus a times 1 minus a. And then c times 1 minus a over 1 plus a times 1 minus a. So in this case, you will get, okay, you will get something here for sure, but here you will get what? 1 plus a, 1 minus a here in the denominator. Okay, now we will follow the same steps. I will not go further because, multiply, doing this operation will not help me a lot. So just I wanted to show you the method here. So sine x, so let's do 1 minus sine x. Okay, multiply both with what? 1 plus sine x, and here 1 plus sine x, minus 1 plus sine x times 1 minus sine x. You multiply with 1 minus sine x both sides. Now, okay, I have this. What about this part? It will be cosine x plus cosine x sine x. And what about this part? It will be minus cosine x minus cosine x sine x. Now, okay, this is important because when combining such multiplication, if there's darb or multiplication or product, so you have to write this one in parentheses when you do it. And then when removing the parentheses, you have to be careful. This will be minus, but this will be plus. Now here you will see some cancellation. Cosine x and cosine x, they will cancel out, and you will end up with, okay, we have this one plus cosine sine x, and there is this plus cosine sine x, and we can put them together. There's no problem. Before proceeding, I want to do something about this part here. What is this equal to? Any idea? So I want to remind you this. If you have something like 1 minus a times 1 plus a, how can 1a, well, how can you do it? Like, it's something like, do you remember such product? Or I would ask you with a and b, what is this? That will be a squared minus b squared, right? So what is a here? A, instead of a, we put 1, instead of b is sine x. So it will be 1 squared minus sine squared x, right? So this product, indeed, it's 1 minus, okay, I'll write in blue. This will be 1 minus sine squared x. So let me write what I got. 2 cosine x sine x. So I'm combining these two, divided by 1 minus sine squared x. What is 1 minus sine squared x? So let's remember this. We know this identity, and here 1 minus sine squared x. So if you send this one to the other side, you will get cosine squared x. So what is this equal to then? This will be cosine x, 2 cosine x sine x divided by cosine squared x. Cosine squared x means cosine x times cosine x. Do you see the cancellation now? So we will end up with what? 2 sine x over cosine x. And what is this? So this is equal to 2 times tangent x. Are we done? Yes, we got this. So, I'm sorry about this writing, but, I'm trying to fit everything. I don't want to erase. I want to keep them in one page so that you can follow the steps here. So we started from the second one, and we got the first one, okay? First term, first side of the equality, or the left or right, you can say. Okay, so I started from this, and I combined the fractions, and I got this combined fraction, and then I used some identities here, and I got this one after the cancellation. I got 2 tangent x. If you didn't understand it, please replay, like slow it down or stop and try to do it by yourself. Because here you have to use the identities. And how can you get more experience? Of course, trying to do the exercises. Okay, please do the additional exercises, do the worksheet problems, do the exercises in the book, or we give the book exercises as textbook, as additional exercises. You can find them in the book, by the way. Okay, let's see how it is told in here in the slides. So this is how you make the denominator same. Divide this one with this and divide this one. Multiply the fractions to make the denominators same. So multiply the denominators, kind of. Okay, then you write this one as 1 minus sine squared. I told you this is a plus 1 b times a minus b. B squared minus b squared. And then, okay, then do this subtraction and change this one to cosine squared, and then there's a cancellation, and you will end up with this. So it's 2 tangent x. So please try to figure out the steps here. Try to do it yourself. Okay, let's look at the last identities here. Prove or show or verify, they're all same, kind of same. Okay, prove is a little different, but in this context they're all same. So here, how can you show this is equal? So this term here is equal to 1. Now we start from the complicated part, or the crowded part. This is the crowded part. Now what is tangent squared? So you can write here 1 over tangent is what? Tangent is sine over a cosine, right? So it's the squared. So I'm using here, sorry, this is tangent here. Sorry, theta. So we know this tangent theta is equal to sine over cosine. So I'm using this here. And when you flip and take the square, you will have sine squared theta minus sine squared theta over sine squared theta. And sine squared theta is 1 minus cosine squared theta. And then sine squared theta over sine squared theta. This was equal to 1 sine squared theta over sine squared. So this is equal to 1. Yes, this is the kind of middle of the night, so sometimes I talk nonsense, so I'm trying to pay attention. Okay, now let's start. Okay, let's start from this part and let's try to show this one. How can you put them together? These 1 hour secant theta. That's one, and minus 1 hour secant theta plus 1. How can you do such thing? So it's this question is like, how do you do such thing? I think we have seen this stuff, like you multiply both sides, right? So you got this one then. So I will multiply both these terms with secant theta plus 1. So it will be secant theta plus 1 over secant theta minus 1 times secant theta plus 1. And minus, I will do the same here. Multiply. Yeah, we will get secant theta plus 1 times secant theta minus 1. And I multiply 1 with secant theta minus 1. So then what we have is this secant theta plus 1 minus, okay, then you can use parentheses, or I mean you can remove the parentheses and just be careful about this minus here, minus secant theta, and with this minus again it will be plus, and here this multiplication, it's something like this. So what is this equal to? A squared minus b squared. You remember this? So it will be secant squared theta minus 1. They will cancel out and you will get 2 over secant squared theta minus 1. Okay, question. What is secant squared theta minus 1? So do you remember this? Secant squared theta minus 1. How can I do it? Okay. If you don't remember it, just go for the basics. 1 hour cosine squared theta it will be, and then you combine. You can do like cosine squared theta over cosine squared theta. Then this will be like sine squared theta, and so you can put this here. So this is something like tangent squared theta. So it will be 1 over tangent squared theta, and it will give you cotangent squared theta. So okay, I will keep doing it from here. I will keep doing it from here. 2 over secant squared minus 1. Okay, if you don't remember anything about this, go for the basic basic identities, like this 1 over cosine squared. If you do this calculation, you will get 1 minus cosine squared theta minus cosine squared theta, and this is sine squared theta divided by cosine squared theta, and this is equal to what? Sine theta over cosine theta squared, which is tangent squared theta. So we can write this one as 2 over tangent squared theta, which means 2 times 1 over tangent squared theta, or 1 over tangent squared, so it will be 2 cotangent theta, 2 cotangent squared theta, and we got this one. In it, when writing this, we have to write them in order. Okay, so since I don't have this in page, so I go this way. So I did 1 Okay, 2, and then 3, and then 4, and then 5, then 6, 6, 7, if you write them, clearly, I mean, by numbering them, it will be nice. But here, instead of using this cosine, you can use also this identity. Do you remember such identity? Second Pythagorean identity. It was given in the first slide. So you can say this implies what? So you send this one to the other side. Sorry, this is wrong. This is 1 plus tangent squared is equal to secant squared theta. So you can send this one to the other side. You will get secant squared theta is equal to, okay, minus 1 equal to tangent squared theta. And this is what we have here. You can also use this one. Okay, that's it. So thank you very much for watching. Please do the additional problems, because you have to know the identities very well to do this type of exercises, and we plan to ask some essay questions about this in quiz 2.